Evening. Today we will be learning about how to test the normality of a data and what impact does it has on the selection of the test. So we are using the software SPSS here, and to understand the normality of the data, we need to understand that why it is important. So in statistics we have different kind of tests like t-test, f-test and z-test and etc. But all these tests require that the data is normally distributed. Otherwise, giving the results on basis of the outcomes from these tests won't be viable. So to test the normality of the data, we have two tests. One is Kolmogorov and second is the Shapiro-Wilks. The difference between these two tests is that if the number of elements in a data are less than 2000, then we use Shapiro-Wilks, and if the data is more than 2000 elements in number, then we'll use Kolmogorov. So here in SPSS, I have a variable data and it is having 20 values. So logically, we have to use the Shapiro-Wilks test to understand the normality of this data. To check the normality of this data, we'll click on Analyze, go to Descriptive Statistics and click Explore. Now we'll have a tab opened here. This tab has the data, which is the heading of the particular data that I have entered in SPSS. We'll shift it or enter it into the dependent list and check the statistics tabs that whether the descriptives is checked or not. Here the confidence interval for mean, which means the surety of how the data is normally distributed or not, is given. So here we are 95% sure that our data is normally distributed. So we'll click continue and always check that this is checked or not. We'll click continue and go to the plots tab now. Here we'll click that we need the plots also for this normality test. So we'll click normality plots with this test and click continue. Now we'll click OK and the output page will be opened. Now it will give all the descriptives like mean, variance, median, standard deviation, minimum, maximum value, range, interquartile range, skewness and kurtosis also. But the very main thing that we need is the test of normality. Here, as I have mentioned earlier, that Shapiro-Wilk will be our basis for the test of normality of this data. So, as we have a 95% of surety, so our p-value will be 0.05. And comparing the significance value of the Shapiro-Wilk test to the p-value will give us that whether our null hypothesis, that is the data is normally distributed or not, will be accepted or rejected. Now, to reject or accept the null hypothesis, we need to check that if the value of significance is less than 0.05, then we will reject the null hypothesis, and if it is more than 0.05, then we will accept the null hypothesis. So here our significance value in Shapiro-Wilk is 3.316, which is obviously more than 0.05, and thus we'll accept a null hypothesis that the data is not normally distributed. Again, if you remember that we clicked on normality with plot test. So we'll go downward and scroll the window. We'll find some QQ plots, which is normal QQ plot, D10 normal QQ plot, and also a POX plot. Though these plots show us normality distribution of the data, but they are not showing us the exact value. So the tests like Kolmogorov and Shapiro-Wilk come into existence and have more significance compared to the plots. As we get a particular calculated value and we can compare it with the tabulated value and thus accept or reject a null hypothesis. Null hypothesis here will be that our data is normally distributed and we are 95% sure that our data is normally distributed. To check the significance, we will compare the significance value of Shapiro-Wilk as the values of the data are less than 2000 to the p-value, that is 0.05, and if it is greater than the 0.05 value, then we will accept our null hypothesis and say that the data is normally distributed. I hope it was very clear to you, and thank you for your time.